And then when we fill these, we put them all in with the same spin. That's called Hund's rule. And then we go back and add the second electron with opposite spin. And I'm using an arrow with just one barb on it. Okay, so one electron would be hydrogen, 2 is helium, 3 is lithium, 4 is beryllium, 5 electrons, when we have just that one there, that's boron, and then 1, 2, that would be carbon, and so on. Up here, we get this filled in. We're up to neon. That's 10 electrons. So now we go sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and then argon. Okay, we get it all filled up. We're at the end of the row of the periodic table. Potassium, calcium, and so on. But now look here, the 4p is above the 3d. I slid them up, and it just so happens nature gave us a 3D before getting up to the 4P. So now on the periodic table, we're going to move into those transition elements in the middle, and we'll begin filling up the D subshell. And you'll see the transition elements, that portion of the periodic table is 10 elements wide because 5 orbitals each with 2 electrons gives us 10 more. Then we go to the 4p. So that's the way we're going to fill things up. Filling from the bottom is called the Aufbau principle. It's a German word that means building up. And the fact that only 2 electrons can fit into an orbital is called the Pauli exclusion principle. And then finally, the idea that we have to put 1 in each orbital in a shell, in a subshell, before we go back and start doubling up, and that each one has to, the first ones have all the same spin, and then we start pairing up. That's called Hund's rule. Okay, so that's probably good enough for this lesson, and we'll make a new video after this.